Okay, in this last video we're going to wrap up the pricing of bonds and take a look at these next few slides. First we'll start with the price-yield relationship. So this is a very basic notion in bond pricing, and that is that the price moves in the opposite direction of changes in interest rates. So as interest rates go up, prices go down. As required rates of return go up, prices go down. Another way of saying that is as discount rates go up, the prices of bonds would go down. So let's just take a look at that real quick in Excel. What I've got over here is the price of a hypothetical bond. Here in this case we've got a bond that pays $45 every 6 months and it matures in 25 years. And so the thing that we're going to be changing is the yield here, the discount rate. We're going to let that vary from 0 all the way up to 15%. We're going to move it in half-point increments. So at 0, if there is no discounting of the cash flows, that would give us the maximum price of the bond, the maximum value, which would just be the sum of all of those coupon payments plus the $1,000 that we receive at maturity. And then as the discount rate increases, so as we move down this axis to a 15% discount rate, those future cash flows become worth less and less, and the price of the bond goes down in value. So if you look at any of these individual price functions, I'm just using the present value function, the yield to maturity divided by 2 to get a periodic discount rate. The number of periods is 25 years times 2 periods per year. The cash flows are $45 per 6 months, and then $1,000 at maturity. So if I just copy that formula all the way down, I get all these results. If I graph that, I get this kind of convex relationship, and we're going to talk more about convexity here in a future video, but this relationship, this curved relationship, shows how the bond prices change with changes in interest rates. So as rates go up, the bond price goes down, and it's a very straightforward, very fundamental relationship in bond pricing. So let's move on and take a look at discount, premium, or par bonds. So again, a fundamental kind of definition thing for our bonds. Discount bonds are bonds that are priced less than par value, and that would happen if the coupon rate is less than the required rate of return on the bond. So for example, a 0 coupon bond that matures in 5 years and has a required rate of return of 4.83% would be a discount bond. Now 0 coupon bonds are always going to be discount bonds, but in this case, anytime the coupon is less than the yield to maturity, we're going to have a discount bond. So if we look at the calculations here, and I'm not going to go to Excel or the financial calculator for these last several calculations, but if you go and try these yourself, you'll get the result that this first bond, this 0 coupon bond, would be priced at $787.21. That's less than $1,000. It's 78.72% of par, so that is a discount bond. A premium bond, on the other hand, is any bond that's trading higher than face value, so it's got a price that's greater than the face value or higher than the par value of the bond. It's going to be trading at 100+% of par. And that's going to happen if the coupon rate is higher than the required rate of return. So for example, a bond matures in 12 years, it pays a semi-annual coupon of $38.25, and has a required rate of return of 5.45%. So the coupon rate, if we double that 38.25, that would be 7.65%, I believe. So $76.50 every year. So that's going to be $38.25 every 6 months. If we plug all that stuff into Excel or our financial calculator, we would get a result of $1191.93. That again is trading higher than par value of 1,000. So we've got a bond that is a premium bond. And last, we got this special case that a bond, when it's priced at $1,000, when its coupon equals its required rate of return, then we would have the bond being a par bond. And we can look at that in Excel over here. We've got this portion of bonds at with yields less than the coupon rate, and so it's going to be all of these here are going to be priced higher than the par value. So those are premium bonds in this region right here. If it's exactly equal to if the discount rate is exactly equal to the coupon rate, we have this special case where it's priced at par. That's this 1 point here. And if the the yield to maturity or the required rate of return is higher than the coupon rate, we're going to have discount bonds, and that is this region down here at the bottom. So again, very basic definitional things. Let's keep moving here. We get now to the last slide, and we'll see bond prices over time. So we got two cases that we'll take a look at. First, if interest rates don't change, bond prices are going to move smoothly towards par as we get closer to maturity. So premium bonds will lose value over time, discount bonds will increase in value over time, and of course bonds that are priced at par will remain at par the entire duration of the bond. So let's look at that. Well, before we do that, let's look at an alternative case here where we would have interest rates changing over time. In this case, bond prices are going to fluctuate, but they are still going to be converging towards par once maturity is reached. So at maturity, every bond is going to be priced at par or worth the par value, and assuming that we don't have any default conditions. So let's just look at that in Excel real quick. Here, bond prices over time. Up above, if we have no yield to maturity changes. So I've got two different bonds. Bond A is a discount bond, and you can see it's this portion in the bottom here. It's increasing in value as we get closer to maturity. The time to maturity is down on this bottom axis. And the bond Z is a premium bond, and it is moving down in value. It's getting closer to par value as time moves on. So we've got the bonds converging to par value of $1,000 as we get closer and closer to maturity. And again, this particular set of bonds assumes that as we get closer to maturity, there's no change in the required rate of return, no change in interest rates, no change in the discount rate. Down below here, we've got some changes happening in the interest rates. So the interest rates are bouncing around, and just to show you what I've done here, I've picked a random number, basically a random interest rate between 6.99 and 8.99%, and we're just going to let that, each of these cells, it's changing randomly. So if I recalculate these cells, for instance, if I just change it, everything is going to recalculate, we'll get a new picture. But regardless of what I do and what I change, as these random numbers move about, the bond prices, you can see, are just steadily moving towards par value. There's still fluctuations, but they're kind of moving around that steady track towards par value. So regardless of the path of interest rates, we got bond prices that are going to be moving steadily closer and closer to par value over time. And that's a fundamental relationship with premium and discount bonds. So just another thing to keep in mind as we think about bond pricing. So that wraps up the videos on bond pricing, and we'll pick it up in the next topic in the next video. We'll see you then.